Today we want to look at waves, and waves are a fundamental part of nature. What's cool about waves is once you understand how one kind of wave works, like ocean waves and water waves, it applies to all the other types of waves. They have similar properties, including sound waves, earthquake waves, electromagnetic waves, etc. So let's break down what waves are. The first idea is that waves move energy across space and time. Waves are nature's way to transmit pure energy. And what's weird is when you see a picture of a wave, it's just sitting there, but you have to remember that the wave is alive, it's got energy, it's moving, and it's not static. Like in this photo, there's movement, there's energy. So waves travel across time and space is a way to think of it. And another way to visualize this is a wave transfers energy or information like sound waves, internet, Wi-Fi signals, cell phone waves, etc. through space and time, but the key is they don't move any mass. So one example is when you play dominoes. You set up a string of dominoes, you knock down one domino and it hits the next domino, etc. until you knock over, let's say, the 100th domino. So what's interesting is you can set up a wave through those dominoes and you can knock down the last domino in the line without having to pick up the first one and throw it at the last one. Each particle disturbs the next one, and the disturbance propagates through space and time. Now, in terms of waves, there are two main types. There's mechanical and electromagnetic. We're going to focus first mainly on mechanical waves because it's a little bit more physical. You can see it better. And then we'll look at electromagnetic waves later on. Mechanical wave, by definition, requires a medium to travel through. So what do we mean by a medium? A medium just means some kind of substance it moves through. So for example, right now you can hear me because of sound waves. When I talk to you, I disturb the air inside my vocal cords. I don't know if you've ever tried this, put your hand on your throat and talk. And then that shakes the air in my vocal cords, which then shakes the air in my mouth, and then the air molecules, kind of like dominoes, continue to hit each other until eventually it gets to the air by your eardrum, which then shakes this thing called the cochlea, and then your brain turns that into electrical signals, and you say, aha, I hear something. But I don't actually push air into your ears, because that would be kind of gross. That means whatever I had for lunch or breakfast or dinner might end up in your ears, and that's just nasty. So the big idea is something has to move through, rather mechanical wave has to go through medium. And in real life, there are many types of mechanical waves. Obviously, water waves in the ocean. This is a little Red Bull extreme surfing clip I linked to on this Prezi, so you can explore this later. It's really fun. These guys are totally crazy. Earthquake waves, obviously. We've had some major earthquakes recently there, and knowing some of these properties can help us design safer bridges, buildings, etc. Oprah in 2009 was really neat. There was the Black Eyed Peas performing, and then suddenly a flash mob appeared out of nowhere, and you can see in this clip later on there was a very synchronized demonstration of wave properties done by a mob there. This artist named Ben Hughes was trying to experiment to visualize sound waves using soap bubbles and paint and all that with some funky techno music. So something neat to check out later on there. The other main type of wave, besides a mechanical wave, is an electromagnetic wave. And the key idea to an electromagnetic wave, EM for short, is that it's pure energy. No medium is required whatsoever. And actually, this is only something discovered in the last 120 years or so. Before this famous experiment called the Michelson-Morley experiment, and if you want to look it up for a little bonus and do a little mini research paper there, scientists thought there was this thing called the ether that surrounded the Earth in outer space. And in order for electromagnetic energy from the sun to get to Earth, they thought there had to be this invisible substance that fills outer space that's perfectly dense but has no weight or something strange like that. And so what famous Michelson-Morley experiment by these two famous scientists, they basically proved there is no ether, so it's kind of weird. And they actually won the Nobel Prize for that. It was one of the first American Nobel Prize winning experiments, which is kind of funny. They're just basically proving there is no such thing as the ether. But anyhow, electromagnetic wave is basically pure energy. You take an electron and you jiggle it, and by doing that, you generate a whole range of frequencies, and we use that in real life, whether it be radio, microwave, internet's in that range there. So if you're surfing the web right now, you shake an electron fast enough and eventually it gives off what we call infrared energy, which shows up on a infrared camera as heat signature. Then finally a little tiny sliver is what your eyes can finally pick up. Then ultraviolet X-rays used by doctors, and then gamma rays is high intensity radiation. And we actually harness all of these with our technological tools to our advantage there. But ironically, your eyes, you can almost think of yourself as being colorblind. You only see less than 0.1% of the entire electromagnetic spectrum that's out there.